Today, let's look at how to find the z-score. Let's get started. Let's produce some random numbers with a normal distribution first. Let's use the function of and rand, and with a center at, let's say 5 on average, with a standard deviation around 2. So the first number will be produced. Let's do 31. Let's make sure there are 30 numbers in this sample. The count here is 30. It is okay. And let's do a very quick check on its distribution. We can use a histogram. This is not really perfect bell shape, but roughly. Every time, actually, if you refresh this, it will calculate again. It will produce a different number. And, well, should be able to represent the normal distribution, something we're going to look at later on. So, well, let's just copy the value of this row and paste the value only, so we don't have to worry about these changing numbers all the time. So we can find first, let's find the center or the mean of this number, the sample. In Excel, they use AVG as the mean. So the mean, let me check. Yes, correct. It's about 5.74 roughly. That's the mean. So what's the standard deviation? There's also a function of the standard deviation right here. So let's just select this range of certain numbers again. So we find it at STD. Then let's just say that's the mean. That's the standard deviation. What we are looking for in order to find the z-score, we have to find the distance between each number and its mean. The mean, we already found it. It's about 5.7 for this case. Let's give it absolute address. Then we can locate this. All right, let's fix it here. Let's keep changing the shape. A little bit annoying. Well, that's the mean. And what's the distance between your number and the mean, the center? So actually, you have this number, the distance between them. Actually, it's the difference between them. Let's duplicate this so we can find each, like a distance of the distance for each number. So what's the standard deviation of this sample? 1.7 roughly. So also give it the absolute value here, reference. So we do this, 30. And there is a ratio actually. You can also call it z-score. It's related to the normal distribution. Actually, it is a distance, remember, divided by your sample standard deviation. The first one is roughly almost the same, very close. If it is a negative number, that means your number is less than the center or below the center. So that's how we find the z-score. The z-score actually is just another representation of the distribution of the number. So let's roughly, quickly, do another Instagram just to check how similar or same they are. Let's move this below the original number without the scaling. And the z-score actually is the scale of the original number on the sample. You can see these two distribution are identical. All right, today, thank you for watching.